In this lecture video, we are going to look at completing the square, which is an algebra skill that we should already be familiar with and is necessary as we begin our descent into our discussion of analytic geometry and discussing these different geometric shapes such as parabola, circle, ellipse, and hyperbola. Here we have a quadratic equation. We know that it's quadratic because it has x squared, and it's written in descending order. What we're going to do is talk about the different strategies that we could use to solve this, and most specifically, we could solve this using completing the square. Generally, when we see something quadratic, our first instinct is to try to factor it. This, of course, is not factorable. So the other strategy that you probably learned to use a lot would be the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And that would certainly give us the two solutions. That is not the strategy we're going to use. So we're going to solve this, but we're going to use completing the square so that we can then use the square root principle. And the main reason, again, that we're doing this is so that we ensure that we know how to use this practice. So the first thing we always do is we're going to move any constant terms over to the other side of the equation. And I leave a space because basically what we do when we're completing the square is we're going to figure out exactly what it is that we need to put in that space. So when I move the negative 5 to the other side of the equation, it becomes positive 5. So now I also like to leave myself a space because essentially we're trying to figure out some magic number to put here that makes the left side factorable. And whatever we add to the left, we also need to make sure we add to the right so that it's a balanced equation. First things first, we always want this to be positive 1. If it is not positive 1, if it's negative 1, any other number, we want to factor it out. So here, we're going to factor out a GCF of 2. That leaves me with 2 times the quantity x squared plus 2x plus that magic number. And whatever I'm adding for that magic number, we have 2 times my magic number. So over here on the right, I'm going to have 2 times whatever that number is, because we want to keep it balanced, and we have to add the exact same value to both sides of the equation. Now we need to look at determining what this magic number is. We'll always be able to determine that by saying b divided by 2 quantity squared. Now what is my b value? Here I have that b equals positive 2. So 2 divided by 2 squared is 1 squared, or 1. So what that tells me is now my equation looks like this. I have 2x squared plus 2x plus 1 equals 5 plus 2 times 1. Over here we can see on the right that that's going to simplify to 7. So I have 2x squared plus 2x plus 1 equals 7. The whole point of us determining this magic number was so that what we have here in the parentheses, x squared plus 2x plus 1, is a binomial squared. We can factor this, and this is actually going to be x plus 1 times x plus 1, and that 1 value that's going to end up in there, that's always going to be this, the number before we squared it. So here we'll have 2x plus 1 quantity squared equals 7. Now, this plus 1, it's always going to be that number before you squared it, whatever this is when you squared it. So if we'd had 3 squared here, which gave us 9, we would have added 9 twice. And the value in this binomial squared would be the 3. All right, so once we have it in this form, we have completed the square. And you're going to be doing a lot of factoring, determining b squared, I'm sorry, b divided by 2 squared, and then creating this form. So make sure you understand how I got here. At this point, when we look at solving this is pretty easy for us to solve. We'll divide by 2 on both sides. X plus 1 quantity squared equals 7 over 2. I'd square root both sides. X plus 1 equals plus or minus the square root of 7 halves, and then subtract 1. X equals negative 1 plus or minus the square root of 7 halves. So these are two values. These are two irrational number values that we could have found solving this equation using the quadratic formula. You are not going to be focused on solving. You, as the student in this conics section, are going to be focused on creating this perfect square binomial type form, right? So where we have this binomial squared. So you're going to be factoring a GCF, determining a b, and then adding b divided by 2 squared to both sides of the equation. Let's just do one more example where we look at how to solve one of these problems again. Here I have another quadratic type expression, and we're going to look at completing the square. So I have a binomial squared over here on the left side. All right, running through our steps the same way, the first thing we're always going to do would be to move any of those constants over. So I don't know what my constant is, and when I subtract 20 from the right, I have negative 25. My next step is to factor out a negative 1. If this coefficient, my leading coefficient on my quadratic expression, if it is any value other than a positive 1, you must factor a GCF. So I'm going to factor out a negative, and that leaves me with x squared minus 6x plus some magic number equals negative 25. And again, we're going to add that magic number to both sides of the equation. But minus that magic number, we're going to have a minus whatever that value is over here. So let's look at b. b is negative 6. That means my magic number is b divided by 2 quantity squared, or negative 6 divided by 2 squared, or negative 3 squared, which gives us a positive 9. So now what this looks like is negative x squared minus 6x. I'm going to add 9 to the left. And of course, when I added that 9 to the left, I'm also going to add that 9 to the right. But how many of those 9s am I adding? I'm adding negative 1 of those 9s. So that's essentially subtracting that 9. All right, so I have negative x squared minus 6x plus 9 equals negative 34. Now, a couple things. I can divide on both sides since they're both negative. I can divide on both sides by that negative, and I have x squared minus 6x plus 9 equals positive 34. So if I look at factoring the left, I pick that magic number so that this would be factorable. How would I factor this? And that would be negative 3 times negative 3. You'll notice negative 3, that's the value we had in our parentheses over here before we squared for our magic number. So the left side becomes x minus 3 quantity squared equals 34. Now we have put this into our completed square form. This is the goal, being able to take something that looked like what we started with at the top and end with it in this nice, concise form. Now, once you're there, you're going to be done in trig. But if we're solving this as if it was an algebra problem, we would end up with x minus 3 equals plus or minus the square root of 34, which is x equals positive 3 plus or minus the square root of 34. So those would be the two solutions to this quadratic equation. So just a recap, we know how to solve any type of quadratic equation using the method of completing the square. Again, our goal in trig is to be able to complete or create this completed square form, because that's what we're going to need in able to determine our vertex, our center, and any other values for our different types of conic sections. So that's your little algebra review. I'll see you in a second when we get started on our conics.